There's our first question. Find the domain of the following rational function. Can you find the domain of that thing? Yeah. How do we find the domain of that thing?
The denominator needs to be set greater than or equal to 0.
Has to be set not equal to 0.
Not equal to 0.
Right? Yeah. Remember that? Remember these kind of, this could have been on the last exam, huh? This isn't really anything new. Excuse me. Yeah, so remember for domain, we have two issues for domain for an equation. They give you, if they give you a picture, domain is just the width coverage, left edge to right edge. But if they give you a function and they ask you domain, then we have two issues, right? It's looking for trouble spots. Remember I said like not putting knives in the toaster. Like what's the domain of a toaster? What can you put into a toaster? Well, you would answer that by really saying what you can't put in. You can't put in knives, etc. So that's kind of what we do with domain for a function. We say, well, you can put anything you want in, except there's a couple things you can't do. What can't you do? You can't make the two things are you can't make denominators 0, because dividing by 0 is undefined, and you can't put a negative in a root. So if you have any square roots, you got to set the inside greater than or equal to 0, right? So we don't have any roots, but we have a denominator. So we say, all right, denominator, you cannot equal 0. So x plus 1, you cannot equal 0. We don't even care about the numerator at all. No trouble spots there. All right, so solve that thing, move that over. X cannot equal -1. That's the answer. And they actually let you type that in. Like you don't have to do interval notation. When you click on the thing, you'll see that there's actually a not equals symbol on the palette. So it's a lot easier. You don't have to make, remember before we'd have to go -infinity up to -1, united with -1 to infinity. You don't have to do that on this one. So. Yeah, so again, you just take the denominator and you say, all right, x minus 3, x plus 5, you cannot be 0, which means x minus 3 can't be 0, and x minus 5. Because if either one is 0, they're going to multiply to be 0. So jump it over, just change the sign. So x cannot be positive 3, x cannot be negative 5. So x can be anything except those two. Again, it'll let you type it in like x cannot equal 3, -5. I think. Play around with it. I'm sure you'll figure out. I think they let you type it in just like that. All right. All right, so try that one, guys. I'm going to run through roll while you work on that one. That one's harder, right? You know what you got to do? You got to grab that denominator. You got to say denominator, 5x squared minus 34x minus 7. You cannot equal 0, right? So what do you got to do? You got to factor that thing, don't you? And I know this is a harder factoring one too. This is a pretty tough factoring. You know what I mean, like with the 2 parentheses? So you got to figure out what would FOIL to become that. You got to basically FOIL backwards. That's what factoring is multiplying backwards, unmultiplying. So I've noticed over the years that people are rusty on their factoring. So I'm going to walk through it with you, but let me let you try it first, and I'll run through roll. Run. Should have wrote for me. Kevin after class. Victoria Alonso is here, and Katharina is here. Thea is here. Emmanuel is here, and Gerswaf. No Gerswaf. And Carlo is here, and William Christman. Thea, where is he? All right, and Eros Cordova is not here, and Tanya Quaco is here, and Kelton is here, and Shane is here, and Tim is here, and Edgar is here, and Jessica Farmer, Ron Fu is here, and Ray Garcia is here, and Ivan Gonzalez is here, Martin Guadalupe is here, and Seth is not Seth, and Shadow Lee is here, and Phoebe Lopez is here, and Mong Lord is here, and Celeste is here, and Marvich is here, and Antonio Medina is here, and Isaiah Mendez is here, and Malik. Malik. And Robert is here, and William Nelson, right? And Juan Olia. And Benita is here, and Tanya Ramirez is here, and Michael Rukava.
Yeah.
And Mohammed is here, and Christian here, and Brianna is here, and Jorge Sarabia is here, and Guadalupe, no, Linda. And Ana Eri is here, and Orlando Soto. Orlando, okay. And Vincent Tao. And Paras is here. And Destiny Valenzuela, or Destiny. And Chang Vang, Chang is here. And Diego Vargas is here. And Lisa Song. And Richard Zong No. And Samuel Zong. And Chu Yang is here. And Fidel Zuniga is here. All right, so let's try this one. So, how are you guys on factoring? Are you okay with that? There's a million ways. I don't care, what way you do. I'm just going to write FOIL to help with the guess. I'm just going to guess and check. I'm just going to guess around until it all works out. I think that's the quickest way. I mean, eventually, if you do more and more of these, that's what everybody does in higher math, because they've done so many of them. They don't want silly little methods. They can just do it because they've done a million of them. But anyway, whatever way you want's fine. Front. So the F stands for front times front, right? You have a front times a front to make a front, right? 5x times x. And you can put the x first, then the 5x. The order on the first two doesn't matter, but the order in the back two will, because then they're going with either an x or a 5x, and that'll matter. But the order in the first two, who cares? Now jump to the last. Don't save the middle. Do that in the end. But go to the L, which stands for what? Last times last. The last in the first parenthesis times the last in the other parenthesis. The two last have to multiply to be 7. Don't worry about the signs yet. Too much to worry about. We'll get to the signs later. Just think 7. Forget about negative. Just what times what's 7? Well, 7 times 1. Right? But that's the wrong order. How do I know? Well, we'll see. So don't worry about signs. I'm just thinking 7. I'm not worried about negative 7. I'll get to the signs when I do the middle. The middle will tell you the sign story. So I've got front times front, making front. I've got last times last, making last, except for the sign. But now, how about the middle? That comes from OI. What does OI stand for? Outer with outer, inner with inner. 7 times x, 5x times 1 is 5x, right? Can they make the middle negative 34x? Not even a chance, right? By adding or subtracting. 7 and 5 is 12. If you subtract them, it's 2. Not even close. So what does that mean right away I need to try to do? Swap the order, right? You put the 1 here and the 7 there, and then try your middle stuff again. Now I haven't, the front is still 5x times x is still 5x squared, and last is still 7. That's all good. But check the middle now. The 2 inner is 1x, the 2 outer is 35x now, huh? 5x times 7. Can 1 and 35 make negative 34? Yes, they can do it. The sign in the middle always goes on the bigger. So plus 1 minus 35 makes minus 34. And that tells you where the signs go. It's a plus on the 1, the minus there, right? Because that sign always goes straight there. There it is. There's the factorization. So you need to get to where you can do that, especially if you're going into calculus. You need to be able to factor. My experience has been many are shaky at this level. You need to shake that shakiness out during the next 2 months. It's one of the things you need to do if you're going to have a fighting chance in Math 5A. All right, so we have that factored. Now what do we do from here? So again, if you're like, I never know if it's right or wrong, you know what you should do is just FOIL it out. If you're not sure, if you've written it and you're not sure, what if I wrote that and said, I don't know, is that really right? Just FOIL it. Just go over here on the side and go, is 5x plus 1 times x minus, is it right? Boom, boom. 5x squared minus 35x, boom, boom, plus x minus 7, that's what? 5x squared minus 35 plus 1 is minus 34x minus 7. Oh, yeah, it's right. How long did that take me? 20 seconds? That's it. And you say, yeah, but I do that, it's wrong, it's wrong. Just do that more and more and more and more. The more you do that, pretty soon you'll be able to see those patterns, and you'll be able to just write it out. So that's it. There's just no shortcuts. You gotta get to that comfort level. All right, anyway, let's finish up this problem. So it's factored. What do you do now? We got to finish up. We got to set each one equal to 0, huh? Each one equal to 0, because if two things multiply to be 0, either one could be 0. So jump it over, jump it over. 5x is negative 1, divide by 5, and 7. So 7 and negative 1/5. Oh, can't be, huh? That's supposed to be not equals, isn't it? I lost my train of thought. So, in the end, our answer is x cannot be negative 1/5 or 7, but it can be anything else. Good? Questions on the factoring? I'm glad to help. That's the kind of stuff I'm eager to help you with. Even just grab me after class. If you're trying something, you don't know why it doesn't work, grab me after. All right, try that one. Let me give you just a second. See if you can find the domain of that one. Answer is, if I take that denominator, so all right, denominator. Again, I'm ignoring the numerator. It has nothing to do with the numerator, huh? Just, hey, denominator, you can't be 0. And he says, great, I can't be 0. I never could be 0 anyway. Right? Do you see that? Can you just look at it and know that? X squared plus 5, how's that ever going to be 0? If you're not sure, go ahead and solve it formally, but you don't have to. Right? X squared, bless you. And then put the roof on the house, up and down the ladder. That's imaginary. So x, you cannot be imaginary. Okay. So he can be any real number, huh? So the answer would be all real numbers on that one. Make sense? Is that okay? No way that can be 0. If you square something and add 5, it's going to be 5 or bigger, isn't it? Even if you plug in a negative. Even if you plug in 0. All right, let me just do this one for you. They're being tricky. Whoops. Yeah. Excuse me. Wait, do I need to... okay, so this one, denominator not equal to 0. Oh, yeah, no, it's not tricky. No, I'm confused. Domain, it's the same thing. Just take that denominator, say, all right, 3x squared minus 81 cannot be 0, right? That's still true. Factor it. You guys know that one's x plus 9, x minus 9, huh? Hey, what if that was x squared plus 81? I ask this every day, don't I? You can't do the double added, right? You guys are like, we got it, Mr. Heron. We got it. All right, I hope so. So, yeah, anyway, so the minus can be done. The double minus, the x 9, the double minus can be done. The plus can't, but we did it. And then said each part that has an x, that 3 just fully ignore, right? That 3 has nothing to do with making anything 0. Does that make sense? If I said, hey, guys, I'm thinking of 2 numbers, and 3 times the first number times the second number equals 0. What would that mean logically? That would mean this one could be 0, or that one could be 0. It wouldn't mean anything about the 3, would it? Right? See why I'm okay logically to ignore the 3? The 3 means nothing, right? Because it doesn't have an x, right? If it doesn't have an x, it can't vary. It doesn't have a variable. It's just 3. So 3 times something is 0. So one of those somethings, one of those unknowns, one of those parts that have an x has got to be 0. So then that means x plus 9 cannot be 0, and x minus 9 cannot be 0. You know the drill. X cannot be 9 or negative 9, huh? Easy enough? Now, I don't know if you're thinking what I was thinking. I was looking at the top, and I was thinking you could factor that top, and maybe something will cancel. And then I realized that doesn't matter. Even if something does cancel, it's still, you cannot plug in 9 or negative 9, because that does make the denominator 0. It does make it 0. So let's try this one. All right, so first off, domain. So I guess we're assuming, I'll put little arrows, on the ends here. We're assuming What kind of graph is this, by the way? Does this look familiar to one of our basic 6?
1 over x.
That's the 1 over x graph. Remember, he has the crosshairs, he has the two asymptote lines that meet, but it's been moved, it's been shifted, right? He has the diagonal branches, right? Anyway, so it's a version of the 1 over x. It's actually in the other 2 quadrants, so it's a negative 1 over x. But anyway, whatever. We're not doing all that right now. So all we're trying to do is domain and range. So what's the domain? Let's start with the domain. What's the domain of this thing? Now, when you have a picture instead of an equation, domain is just on the picture, right? It's left edge to right edge. So domain would be from here to here and from there to there, but not the middle, huh? So domain would be negative infinity, whoops, it's a funny 0. Negative infinity to 0 to the middle, united with 0 to infinity. Or I think they might want you to put a comma in between. On test, I don't care. Comma in between, a U in between, whatever they want. I forget. They'll tell you. If you're not sure, remember you can click on the question help, show me an example, you'll see the format they want. So I think they suddenly changed their mind. Remember they always wanted U's before between them? Now I think they suddenly changed their mind and they want commas. Like I said, on test, I don't care. So is that good to there so far?
That would be 4.
It would be 4, yeah.
Oh, it's 4, thanks. So that's not okay. Yeah, it's not 0, it's not in the middle, it's 4, thank you. 4, yeah, so it's right here at 4. Yeah. So it doesn't, neither one touches the 4. It's parentheses next to the 4, so you never touch the 4, huh? That's a fancy way of saying everything but 4. What's the range? The range is the up-down, huh? So I'm kind of erase this stuff. So the range is the same thing, it's up-down. So basically it's there, and it's there, huh? So it's everything but, what is that, negative 4? Everything but negative 4. So negative, so from negative infinity down here to negative 4, and from negative 4 to positive infinity, huh? Good on that. So domain and range from the picture. Next is the intercepts. Like where does it appear to hit the graph, the axes, right there, and that's it, 0, 0. So the intercepts are just 0, 0. That was easy. Horizontal asymptote. Well, you see it right on the graph. There's the horizontal asymptote. That it hits the y-axis at y is negative 4. So it's y equals negative 4, huh? And the vertical asymptote, which is right there, whoops, and that's hitting the x-axis at positive 4. Good. Oblique, that means a diagonal asymptote. We'll get to that. There's no diagonal dotted lines on this one, so we're done. Good there. So those are pretty. All right, so domain and range of the function. All right, so it looks like one of those is a vertical asymptote, huh? One of those is going straight up and down. One of them is diagonal, what they call oblique. All right, so domain and range of the function. I guess those are branches, those blue graph, the graph itself, you know, the blue things. They almost look like straight lines, don't they? But they can't be because they have, because remember what an asymptote line is? It's a line of approach, right? It's a guideline. That's a better way to say it. It's a guideline. It's a line that guides the graph, right? So the graph gets closer and closer and closer to the asymptote line forever, right? So therefore, when I know, let me use the right color, when I know this asymptote line goes up, 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 and this one goes down, 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 and this one goes diagonal like this. Let me just extend this a little bit. Might be more clear. Like that. Okay. So then the graph itself must go like this, and go up like this, and go like this, and go like this. So that's what we're talking about for the graph. Make sense? It's extending it a little bit. All right, so maybe that'll help us now. So what's the domain and the range? So what's the domain? What is the left to right kind of domain is, you know, how far left? How far left, first off? Yeah, there's graph. See this arrow? It was going left forever, right? This top branch here. He's saying, I'm going up and left forever. So he'll go left forever. There'll be graph left forever. Negative infinity up to what? Up to 0, huh? Remember, you can never touch, a graph can never touch a vertical asymptote line. You can hit horizontal and oblique. Want me to write that? You can never touch a vertical asymptote, but you can hit horizontal or oblique, which means diagonal asymptotes. So, it never, and we'll talk more about that. It's because the vertical always makes the denominator 0. Basically, that's the story, right? You can never be a value that makes the denominator 0. So, it doesn't, the graph, notice the blue graph never quite touches the middle, does it? It never touches the middle. So, it doesn't quite make it to 0. But then, off to the right, it goes from 0 to positive infinity because this bottom piece goes down and right forever, so he's going right forever. So, the domain, then, is negative infinity 0, comma 0 infinity. We good? What's the range? Range is the up down. What do you guys think about the range? Yeah, it goes as low as you want to go, goes as high as you want to go. Right? There's a graph, down, down, down forever, and up, up, up forever. No breakings. Everybody see the sideways, the domain is broken at 0. No blue graph ever hits the very, very middle. It gets real close, but never hits the very middle. But vertically, the graph hits all the y values. Negative infinity to positive infinity. Okay, what are the intercepts? Where does it ever hit the axis? This thing's a big mess. Let me get a fresh one. All right, so intercepts. Oh, that's just right on the graph, huh? Oh, they're right there for us. So 2, 0, negative 2, 0. That was nice. All right. There's the intercepts. All right. C, horizontal asymptotes. None, huh? No horizontal asymptotes. D, vertical. Well, that's right there in the graph. So the vertical. Vertical. Where does it hit the x-axis? At 0, right? Right there. There's the vertical. And then the oblique, which is the diagonal, that's, of course, you know, this one right here. All right, so he is a y equals mx plus b, isn't he? Right? It's a line equation, huh? The vertical and the horizontal, they only have x or y because they're perfectly straight up and down or perfectly sideways. So they don't slant at all, right? So they just hit the x-axis or just hit the y-axis. So they just have x or just have y. But the oblique, which means diagonal, the diagonal one, he's got a slant to him, so he's a y equals mx plus b. What's his slope? Can you tell what his slope is? That's over 2 down 8? Yeah, negative 4. Good, good. Because going down, right? That line's going down to the right. So it's got to be a negative slope, right? Lines that go down to the right, negative, up to the right, is positive slope. Yeah, you can tell rise over run. You remember slope is rise over run. So it goes what? Down 8 over 4, huh? Down 8 over, 2. Down 8 over 2, right? Down 8 over 2, so the slope's negative 4. Is that good? Or you could have just done, 0, 0 if you want to be more formal. y2 minus y1 over x2 minus x1, I'll say or, which is the point, this is the point 0, 0, origin, and the point 2, negative 8. So you could have said, okay, it's negative 8 minus 0, y2, y1, that wasn't good. x2, y2, x1, y1, and then over x2 minus x1, negative 8 over 2, same thing, negative 4. So the slope is negative 4, however you do it, rise over run, or difference of y's over difference of x's. Negative 4, so we got a slope, negative 4x, and what's the b?
0.
The b is 0, so it's just negative 4. Right, because the b is where it hits the y-axis, the y-intercept. Right, it hits the y-axis right there at the origin. Runs into the vertical axis right there at the origin. So y equals negative 4x plus 0, or just y equals negative 4x. That is the oblique asymptote line. Good on that? We're going to get back to the graphing where we find the center point and one other point, So basically, this is y equals 1 over x with a minus 9 thrown in there, right? So let me put that minus 9 in there. Minus 9 plus 1 over x. So we know it's going to be like the, as soon as you see that 1 over x, you think, okay, that's the one with the crosshairs, with the 2 asymptote lines that cross, and then we have the 2 diagonal branches, right? So anyway, so with that in mind, go ahead and go about your business like normal. Your business being make an XY chart, find the center point. How do I find the center point? What do we always do for all the graphs to find the center point? It's whatever makes the x zone, x is a little world, 0, right? So what can I plug in there, guys, to make the x world 0? And there's x's little world. It's just 0, huh? So when I do that, negative 9 plus 1 over x, so I get negative 9 plus 1 over 0. What's that? Yeah, that's undefined. You can't take 1 divided by 0, right? That's error, undefined, right? But remember what I told you to do. It's completely illegal, but very helpful. Just pretend the undefined part, not the whole thing, but just the undefined part. We take this piece and we say, let's pretend, here we are in math class, pretending. Pretend the undefined part is 0, right? We already pretend, don't we? We got imaginary numbers. This isn't anything new. We've been pretending for a long time. All right. Negative 9. That would be negative 9 plus pretend 0 would be negative. Now, why do we do that pretend? Because it's very helpful, and it tells us exactly where the center of the asymptote lines is, the crosshairs, right? So we go, oh, okay, over 0, down 9. 1, 2, 3, 4, 5, 6. Oh, I should have made this. I didn't think ahead. Let me try again. All right. How about that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Boom. That will be the center of the crosshairs. I'll put another one this way. The center of the asymptotes. That makes sense? That center is the new center, right? Normally the asymptotes meet in the origin, huh? Now they meet it over 0, down 9. Is everybody catching that? Often, I know this is tricky for people a lot of times. So you do what we always do with all these functions. Plug in what makes the x zone 0. And then when you get the undefined, you pretend that part is 0, so it's negative 9. That is the new center. Very helpful point. Then what do we do to find the other point? Add 1 like always. Just add 1. What are you going to get? Negative 9 plus 1 over 1, right? Plug it in right there. X is 1. Negative 9 plus 1, negative 8. So over 1, down 8, right there. Good there. Over 1, down 8. This is over 0, down 9. This is over 1, down 8. Right? Now, just that one dot? Is that enough? It really is, to have a feel. What that means is there's a branch here in this quadrant. And where must the other branch be? Down here. They're diagonal. Remember, they're always now. What if that dot, that other dot I found, was like over here? That would have meant there was a branch here and there, huh? So it's really telling you, and they can happen when they flip the thing, that happens. So that tells us where the two branches are, and we're good. Hopefully that'll answer the question. Which one of those is right? B, is it B? Yeah, it looks like B here, yeah. That's what I'm thinking too, B. Yeah. Does that make sense? Is that good on that? Questions I can answer? Good? All right. So. All right. Shall we try that one? So y equals 9 over x minus 3. So yeah. Go ahead. I won't say anything. Go ahead, give it a try. Same thing. Make the xy table. Right? Make the xy table. Plug in what will zero out the x zone. Go find the center. I'm finding little marks on my iPad here, so I'm scribbling things off every now and then. A couple weeks ago, my kids played with the iPad at home. My 10-year-old girl was putting her finger in her nose, as 10-year-olds do, and then sliding things around on the iPad. My 21-year-old son said, maybe you shouldn't use your nose while you're using the iPad. Makes it real slick, though. It moves real quick that way. All right, so what are we going to do? So we want to xy here. Whoops, I'm not on the pencil. Xy. So what's the center? What do we plug in to zero out the x zone? 3, right? So you got to plug in 3, and that'll make remember the x world, the x zone is the parentheses, right? If there are parentheses, right? So what's right in x's little world. So if you plug in 3, that'll make x's little world 0. Well, then what are you going to get for y? Y is 9 over x minus 3 squared, so y will be 9 over 0. Let's do this one. All right, so try that one. Let me give you a second. All right, what needs to be done? Yeah, did everybody see you need to factor that denominator, huh? So go ahead and factor that denominator. It needs to be factored. You got to have the parentheses. So this is y equals -1 over x plus 1 squared. Everybody okay with that? That's x plus 1 squared. If you check it, you can check it. What is x plus 1 times x plus 1, boom, boom, x squared plus x, boom, boom, plus x plus 1, x squared plus 2x plus 1. See how that's right? We good with that? Now, do our regular stuff, you know. Meaning make the table. XY table, find the center point, find one other point. In fact, yeah, can I, well, go ahead. So what am I going to plug in for the center point? Yeah, whatever zeroes out the x zone, that'd be -1, huh? And so then you get y equals -1 over -1 plus 1 squared, -1 over 0, which we pretend that undefined is 0. So that means back 1, up 0, there is the center of the asymptotes. Center of the crosshairs. We good to there? Back 1, up 0. We okay with that? Now, what do? You add 1. That'd be 0, huh? Add 1, plug in 0. What do you get? -1 over 0 plus 1 squared. That'd be -1 over 1, -1. That okay? -1 over 0 down 1 over 0 down 1. Right here, over 0 down 1. This is back 1 up 0. And so what does that mean? Well, that means you got a branch here. And where's is the other branch side by side or diagonal? Side by side because it's a second power, so it's over here. Like that. So which answer is it? Yeah, it looks like D, huh? Again, not multiple choice on our test in a few weeks. It'll just be just like this. It'll be just what we just did, would be what I'd ask you for. Center point, one other point, basic graph. Good on that? All right, the next one. All right, try that one. Center point and one other point. So what am I going to plug in for the center point? +2. Right? Whatever will zero out the x zone, the parenthesis x world, right? So plug in whatever will zero out the x zone. That'd be +2. And then find your y from there. what do we got? So negative 2 plus 2 over, that's just going to make 0. So remember, you pretend that the undefined part is 0. So then it's minus 2 plus 0, which is minus 2. Huh? So this is over 2 down 2. We good with that? Boom, right there. Over 2 down 2. That's the center of the crosshairs, isn't it? Center of the asymptote lines. So there we go. And then we add 1, plug in 3. What do we get? Negative 2 plus 2 over 3 minus 2 squared. Negative 2 plus 2 over 1. Is that 0? Yeah, 0, huh? Over 3, so 1, 2, 3, up 0 right there. So over 3 up 0, this was over 2 down 1. So here we have a branch. Are we good so far? Am I racing ahead too quick? Is that making sense, what I did there? So I plugged in the center, whatever will zero out the x zone. The undefined part, you pretend is 0, so negative 2 plus 0 is negative 2. So over 2 down 2. Oh, that's supposed to be down 2, huh? Messing that up. Over 2 down 2 is what that is down 2 here. Down 1 down 2. Over 1 over 2. And over 3. So, and then the other point, add 1, it's 3, 0. And now, the other branch, so we got one branch, that shows us where one branch is. Now, is the other branch side by side or diagonal? Yeah, because we have a second power, it's side by side, so it must be over here, huh? So there's the two branches. Good. Questions on that one? You guys feeling like lean, mean graphing machines now? They're going to try to trick us, so we got to be careful. It's algebra, basically. So they're giving me this, okay, y equals, let me go back to that. Y equals 7x squared minus 6 over. Somehow we have to do some algebra thing to that to make it look like the functions we've been dealing with. What do I mean? Either look like a 1 over x or a 1 over x squared, because those are the two we've been dealing with. So, like, that just looks weird. 7x squared minus 6 on the top, that's not really accurate. I don't think it would, not easily. You know, it's actually not that hard. What you want to do is just separate, make it into two separate fractions. You know, common denominator reverse, you know, just separate denominators, right? And then you can cancel these. Does everybody know you can't cancel them back here? Like, that's illegal? Do you know that? It's an important thing to know, especially, it's like I always say, moving on into calculus. Pluses and minuses glue things together. I don't know if I've ever mentioned that. If I say the Costco, it's like shopping at Costco where they plastic things you got to buy in bulk. Same kind of thing. Pluses and minuses in algebra are like that. When they glue things together, they connect them. And so you can't break the connection. You can't go to Costco with your scissors and cut it. Say, I just want one milk. No, they won't sell you one. That's how they make their deal. They sell you a bunch of them or nothing, right? That's kind of like what pluses and minuses are like in algebra. They glue things together. So you can't buy just one. When they're glued, that means if you want to cancel something, you go like that, and you buy the whole package, or you don't touch it. When it's plus or minus together, you buy the whole package, or you don't touch it. There's no taking part of the package when there's got pluses and minuses. That's why pluses and minuses kind of wreck algebra. They're what make it hard. All the hard rules in algebra are always involving pluses and minuses. Multiplying and dividing is simple in algebra. It's the pluses and minuses that make a problem. So that's why I separate these into two separate fractions. And then, boom, I can cancel those because that's just 7 times x squared. That's just shopping at Save Mart. You can buy just one, right? I can take there's no problem. The 7 and the x squared are not glued. They're not a package deal. They're just times. You can cancel, right? So that's why we separate them. So what? So why is that so great? Because now this is a form we can handle. Now we can do our regular thing. Make the XY table, plug in the center. Now it looks like what we're used to, right? What am I going to plug into for the center? 0, because that'll zero this out. Y is going to be 7 minus 6 over 0, which we pretend that's 0. So it's 7 minus 0. And so that's 7. So over 0 up 7 is the center. And we're out of time, so I'm going to go dot, dot, dot. You get the rest. So the whole thing was that first algebra step. All right, this will be due on Monday, not